Tell me an plus 1 is what? So an plus 1 is what? So replace n by n plus 1. Some students make a mistake here. Okay? So here should be n plus 1 minus n plus 1 the whole square. Okay? So from here we have an plus 1 minus an equal to what? Equal to n plus 1 minus n plus 1 square and minus n square. We have obliterated here. Okay? So you just compute it, open it. Open it. So open the expression with n plus 1 minus n square minus 2n minus 1. And minus n minus, so plus n square. Here minus n square, here plus n square, cancel. Here minus n, here n, so cancel. Here plus 1, here minus 1, so cancel. So we just have the minus 2n. So the result is minus 2n less than 0. Less than 0, so here means an is greater than an plus 1. So this means this is strictly decreasing. Okay? This is the first one. And the second one. And the second one here, an equal to what? An equal to n times e minus n power. And so an plus 1 equal to what? So an plus 1 replace n by n plus 1. So here is n plus 1 e minus n plus 1 power. So we have this, okay? So from here we have an plus 1 by an equal to what? So here an plus 1 by an. So here should be n plus 1. Here is e minus n plus 1 power by here is n. Here is e minus n power. Yeah? So now here actually is easy to see. Here is e minus n minus 1 power. So here we can rewrite it in n plus 1. Here is e minus n minus 1 power. Minus n minus 1 power actually is e minus n power times e minus 1 power. So by n e minus n power. So here we can see e minus n power cancel. So here should be what? Here should be n plus 1 times e minus 1, and here is n. So we times e on both sides. On both sides. So here actually is n plus 1 by ne. So here n plus 1 by ne. So here now we can see ne. E actually approximately equal to 2.7. So here actually is 2.7 and here is n plus 1. So n plus 1 and 2.7 n, which is greater? So here of course this is greater than, the denominator is greater than the numerator. So here actually is less than 1. So here less than 1, so here means an is greater than an plus 1. So this one is also strictly decreasing. Okay? Strictly decreasing. So this is the second one. And the third one, and actually the third one is so easy. Okay? So here we use the definition. So we use the definition, so here the function is what? So the fx actually is arc tangent x. Yeah?
Yes.
Arc tangent x, so f prime is what? F prime is what? 1 by what?
1 by 1.
1 by 1 plus x squared. Yeah? So this is greater than 0 or less than 0? X squared is positive. 1 plus positive.
It's
Positive. 1 by positive. 1 by positive. So greater than 0, yeah?
Yes.
So here means f is steadily increasing. So here means this is the strictly increasing, okay? So this is the three method, okay?
When, like, can you give us an example where it's going to be increasing, not strictly, just increasing or decreasing?
So here this one is 1, 1, 1, 1, 1, 1, 1, 1. This is constant. So this is increasing or decreasing?
Increasing, yeah?
It's a constant.
Yes, it's neither.
So it's increasing or decreasing, steadily increasing, steadily decreasing.
Nothing like that.
So actually this is for any, we have an plus 1 equal to an for all n, yeah?
Yeah.
So you can see this, actually here, you can see this is increasing, yeah? Of course you can see it's decreasing, alright, alright.
What?
Because this one actually is, you can see A1 is less than or equal to A2, A2 is less than or equal to A3, yeah? It's right, yeah? So of course it's increasing, yeah? Of course it's also A1 is greater than or equal to A2, is greater than or equal to A3, yeah? So of course it's decreasing. So this is, so I tell you three methods to see the sequence is increasing or decreasing, steadily increasing, steadily decreasing. So keep in mind, okay? Keep in mind. Keep in mind these three methods. And when I give you a sequence, you can use these three methods, okay? So now we will go to the second part. So the second part now we see the page 452. 452. Here now, just now I introduce a sequence, this sequence, okay? 3, 1, 2, 3, 4, 5, 6, go on, and so now we just see this sequence actually is not increasing, not decreasing, okay? Because we have 3, this is greater than 1, but 1 is less than 2. So this is not increasing, not decreasing, okay? But actually, if we just see this part, okay? 1, 2, 3, 4, 5. So this part actually is strictly increasing, okay? So in mathematics, for this case, okay? For this case, we do not see the finite term, okay? We just see the following part, okay? So for this case, in mathematics, we call it what? So we call it the means the eventually, okay? So eventually strictly increasing, okay? So means the eventually strictly increasing, okay? So here we have a word, means the eventually, okay? Eventually. So here we should give the definition. So the definition is the 10.2.2, okay? So if discarding, okay, if discarding finitely many terms, okay, finitely many terms, from the beginning. From the beginning of a sequence. Produce a sequence. Produce a sequence with a certain probability. With a certain probability, then the generally then the origin, okay, then the origin sequence. Then the origin sequence is said to be too high, okay? To have that probability eventually, okay? Eventually. So this is the definition, okay? So here means we discarding finitely many terms from the beginning, okay? So here we do not see finitely many terms from the beginning of a sequence. Produce a sequence with a certain probability. Then the origin sequence is said to have that probability eventually, okay? Eventually. So here. So this is so now for this sequence, so we have the eventually strictly increasing. So now I give an example. So here. So here, show that the sequence 10 to the power n, okay, 10 to the power n by n factorial. This sequence is eventually strictly decreasing, okay. So it's eventually strictly decreasing. So here in this case, because we have n factorial, here is a 10th power, okay. So actually we can use the split method, okay. So for this one, actually the method we should choose the second method. We need to see the quotient, okay. So for this one here now. So here an actually equal to what? Equal to 10 to the nth power by n factorial. So we need to see an plus 1. An plus 1 equal to 10 n plus 1 power by n factorial. So here is, I'm sorry. So here is also n plus 1 factorial. Yeah? So here is n plus 1 factorial. So we need to see the quotient. So the quotient is an plus 1 by an. Okay, an plus 1 by an. So here should be 10n plus 1 power by n plus 1 factorial. Yeah. By 10 to the nth power by n factorial. Yeah. So this is equal to what? So this is equal to 10n plus 1 power by 10 to the nth power. and times n factorial by n plus 1 factorial. Yeah? So here, 10 n plus 1 power by 10 to the nth power. Actually, this one, we can cancel 10 to the nth power. Yeah?
Yes.
So here is 10. The first part is 10. The second part here is m factorial by n plus 1 factorial. So we can cancel n factorial. So the second part actually is 1 by n plus 1. Yeah? So for this one here, so from here we can see this actually equal to 10 n plus 1. Yeah? So now, so we can see what? So this one, when n plus 1 is greater than 10, when n plus 1 greater than 10, so this is actually it should be what? Should be less than 1, yeah? So this should be less than 1. When n plus 1 less than 10. N plus 1 less than 10, so here means n greater than 9, yeah? So when n greater than 9, okay? When n greater than 9, so this number will less than 1. And when n plus 1, less than 10, okay? Less than 10, so here, this should be greater than 1, yeah? So this should be greater than 1. So here means what? Here means when n less than 9, this number will be greater than 1. So when n equal to 9, so here is 9 plus 1, 10 by 10. So this is 1, yeah? So from here we can see what? So when n less than 9, so from here for the first case, okay? Here is an plus 1 by an. This is greater than 1 when n less than 9. And an plus 1 by an is equal to 1 when n equal to 9. Yeah? And when an plus 1 by an should be less than 1 when n greater than 9. Yeah? So this tells us what? Here, this case actually is an plus 1 greater than an, and in this case actually is an plus 1 equal to an, and in this case actually is an plus 1 less than an. Yeah? So from here we have what? So from here it is clear. Yeah? It's clear. So here A1, A2, A3, A4, A5, A6, A7, A8, A9, and A10, A11, A12. Go on. So here from A1 is greater than A2 or less than A2. A1, of course, n, when n equal to 1. A1 actually is less than A2, yeah?
Yeah.
So A1 less than A2. A2 is also, when n less than 9, we have this conclusion. So A2 is also less than A3. So A2 less than A3, A3 less than A4, A4 less than A5, A5 less than A6, A6 less than A7, A7 less than A8, A8 less than A9. Okay? And when n equal to 9, we have what? A10 equal to A9. So these two terms actually equal.
Yes.
And when n greater than 9, so here when n equal to 10, A10 greater than A11. So this is greater than A11 greater than A12. So this is greater, okay, greater than. So here means this is
Eventually strictly.
this part, okay? This part actually is the finitely many terms. Yeah? infinitely many terms. So this actually is we here is A13 greater than A14 greater than here is AN greater than AN plus 1. So it's easy to see here. So this first part, okay, the first 10 terms we discarding, okay, we discarding, okay. So and from here and from here and from here, okay, from here. Actually, this is strictly decreasing, yeah.
Yes.
So from the number 10, okay, from the 10th term, this is strictly decreasing, okay.
Yes.
So now.
So you only take the term after the.
So here, this is from here. So you just calculate this part and to see this is greater than 1 or less than 1. So this is so actually we have some exercise here. So for 454, number 12 or number 19 to number 24, okay? Number 19 to number 24, I hope that you can do it after the class, okay? You can do it after the class.
Oh.
And now we will go on. We will go on. The last section means the convergence, okay, convergence. Convergence of monotone sequence. So now we see some example. The first example here. 1, 2, 3, 4, 5, go on, n. Okay. For this, okay, for this sequence, actually, it's easy to see. It's strictly increasing. Yeah. So it's strictly increasing. So now we can see the limit is what? The limit n when n approaches plus infinity. So the limit actually is plus infinity. Yeah. So plus infinity. So here means this actually we are no upper bound. Okay. No upper bound.
No what?
No
Upper bound.
No upper bound. Okay. So here means this will go to plus infinity. So we do not have upper bound. Okay. We do not have upper bound. And for number 3, okay. For number 3, for this example, -1, -2, -3, -4, go on, -n, go on. Okay. For this one. So the journey term is -n. So for -n, it's easy to see. Limit n approaches plus infinity, -n will approaches what? N approaches plus infinity, -n will approaches what? Minus infinity, yeah. So here means this will go to minus infinity. Minus infinity, so this means actually we do not have no lower bound, okay? No lower bound. Because this is here is a strictly decreasing sequence, okay? And this is a strictly increased bound, increased sequence. So this is the third. So for the number 2, we see this sequence. Okay, this 1 by 2, this is sequence. The first is 1 by 2. The second is 2 by 3. And the third is 3 by 4. The fourth is 4 by 5. So go on. Here is n by n plus 1. N by n plus 1, so go on. So for this one, okay, for this one, we can see when n approaches plus infinity, n by n plus 1 will approaches what? So here, actually you can divide n on both sides. So here actually the limit n approaches plus infinity 1 by 1 plus 1 by n. Yeah?
Yes.
So this will approaches what?
1.
Approaches 1. Yeah? And it's easy to see here this part. Okay? This general term, okay? This general term actually n by n plus 1. N by n is always less than 1. Yeah? It's always less than 1. It's always less than 1, so here means we have a 1 actually is an upper bound, okay? Because for all n we have n by n plus 1 is less than 1. So here means what? Here means for each term of this sequence, actually each term will be less than 1. Of course, it's less than 1 is of course less than 2, yeah?
Yes.
Of course, less than 3, less than 100, or less than 1000. So here means 1 actually is an upper bound. It's an upper bound of this sequence. So here this we have an upper bound. Okay. So upper bound 1. Upper bound 1. So here means this is upper bound. So this is also a strictly increasing sequence. So here tell us what? We can see the first one, the second one is all strictly increasing sequence. So we have two. The first is no upper bound. The second is we have an upper bound. Okay. So the no upper bound actually is when n approaches plus infinity, an approaches plus infinity. And for the upper bound, for the second case, okay. When n approaches plus infinity, an actually approaches some constant.
Yes.
Okay, so this is the second. So for number 4, is the same. Okay, so number 4, for example, here minus 1 by 2, minus 2 by 3, and minus 3 by 4. And minus 4 by 5. So go on, here is minus n by n plus 1. So for this one, for this sequence, okay, for this sequence, it's strictly decreasing, yeah? It's strictly decreasing. So strictly decreasing, and now we can see here, limit n approaches plus infinity minus n by n plus 1 will approaches what?
Minus 1.
Of course, minus 1, yeah? Approaches minus 1. Approaches minus 1. So here, and now we can see, because n by n plus 1 is less than 1. So minus n by n plus 1 is greater than minus 1, yeah? Greater than minus 1. So here means what? For the number 4 sequence, each term is greater than minus 1. Each term is greater than minus 1, of course, is greater than minus 2, of course, greater than minus 3, okay? So here, this, we have a lower bound, yeah? For this one, we have a lower bound. Lower bound is what? Is minus 1. Okay. So here from this four, example tell us one result. The first the result is for the strictly increasing, okay? For the strictly increasing sequence, we have two properties. We have two possibilities. Okay, two possibilities. The first is we know upper bound. The second is the sequence have a finite limit. We have a upper bound. Okay, and for the strictly decreasing or decreasing sequence, we also have two possibilities. The first is lower bound. The second is we have a lower bound and we have a finite limit. So this is the two possibilities. Okay. So here these two results actually is in page 452. 452. 10.2.3 and 10.2.4. So now let's see the book. Now let's see the book. 10.2.3. If a sequence AN is eventually increasing, then there are two. Oh, so here actually we just need eventually increasing, okay, or eventually decreasing. So here, if a sequence AN is eventually increasing, then there are two possibilities. The first is there is a constant n called an upper bound, okay, for the sequence such that AN is less than or equal to n for all n, okay, for all n, in which case the sequence converges to a limit and the limit is also less than or equal to n. Okay? The first. The second is low upper bound exists, in which case n approaches plus infinity and n approaches minus infinity or plus infinity. Okay? This is the first. The second, 10.2.4. Okay? If a sequence AN is eventually decreasing, then there are two possibilities. The first is there is a constant m called a lower bound for the sequence such that AN is greater than or equal to n for all n. The second is in which case the sequence converges a limit and the limit is greater than or equal to n. The second is lower bound exists, in which case n approaches plus infinity and n approaches minus infinity. Okay, so here this actually tell us if eventually increasing. Okay, eventually increasing. We have two possibilities. The first is either we are go to plus infinity. Okay, either we are go to plus infinity. The second is either we are convergence to a limit. Okay, so we just have two cases, two possibilities. The first is either we are go to plus infinity. The second is either we are go to a constant or either we are go to like this. Either we are go to convergence, okay, and have an upper bound. So for the eventually decreasing, okay, for the eventually decreasing, of course, it's the same, okay. For the eventually decreasing sequence, so it's the same, okay. We also have two possibilities. The first is either we are go to minus infinity. The second is either we are converging to some constant. In this case, okay, and we have a lower bound. Okay, we have a lower bound. So in this case means that in this case just two possibilities. First go to plus infinity or go to minus infinity or have a limit. Okay. So now, so this result, these two possibilities you should do remember it. Okay. So now let's see the page 453. 453 example 2. Okay. Show that the sequence converges and find its limit. and find the limit, okay? So here, so show that the sequence 10 to the power n by n factorial, this sequence converges, okay? And find the limit. So here we just show that, we just prove that the sequence actually is eventually decreasing, yeah?
Yes.
It's eventually decreasing. So here, we have shown, so we have shown the sequence. We have shown the sequence 10 to the nth power by n factorial n equal to 1 to plus infinity. This sequence is eventually decreasing. So it's eventually decreasing. So this means what? This means just have two possibilities. Okay, the first is go to minus infinity. The second is have a limit. Yeah. So and now it's easy to see here. N to the nth power is positive or negative. N factorial positive or negative. Positive. So positive by positive. So here this number is positive or negative.
Positive.
Positive, yeah. So and so it's easy to see. So it's easy to see that. So it's easy to see 10 to the nth power n factorial is greater than 0. Yeah. It's greater than 0. So tell us what 0 is a lower bound. Is a lower bound of this sequence. Yeah. So here means this sequence have a lower bound. So have a lower bound, so it cannot go to minus infinity. Yeah. So here means what? So have a lower bound. So here means actually it will convergence. Yeah. So by the series term of 10 to the 2 to the 4. So here by the series term 10 to the 2 to the 4. Okay, this is eventually decreasing and have a lower bound. So here, so by the series term 10 to the 2 to the 4, the sequence 10 to the nth power by n factorial, we are converging. We are converging, yeah? We are converging. So here, so now we know we are converging. So converging. So we need to find the limit. So we assume the limit is L. So we should assume the limit n approaches plus infinity, an will approaches L. This L we need to find, okay? So here, so now we need to find L. So now we see an actually equal to 10 to the nth power by n factorial. And an plus 1 should be equal to what? 10 to the n plus 1 power by n plus 1 factorial. Yeah?
Yes.
So here actually is we can rewrite this part by 10 times 10 to the nth power. And we can rewrite this part by n plus 1 times n factorial. So now we can see this part actually is an. So this is actually equal to what? This is actually equal to 10 n plus 1 an. Yeah. So here means an plus 1 equal to 10 by n plus 1 by an times an. So now we take the limit on both sides. So we take the limit on both sides. So here means limit n approaches plus infinity, an plus 1 equal to limit, here is a product. So limit of a product equal to the product of the limit. So here is n approaches plus infinity, here is 10 by n plus 1 times limit n approaches plus infinity an. Yeah? So now we can see this limit is what? This limit is L. Yeah, so here is L. This limit is what? 10 approaches plus infinity, 10 by n plus 1. Of course, what?
0.
N approaches plus infinity, 10 by n plus 1 approaches what?
0.
0, yeah? And this is what? This is also L, yeah? So here means L equal to 0 times L. So here means L equal to what? Equal to 0. L equal to 0. So this is the first method, okay? Actually, we have another method for this one. For this one, so here we use the total behavior and the part behavior, okay? We use the total behavior and the
Part behavior.
So here actually the total behavior and the part behavior is not vivid here. So because here if here is x factorial, so x factorial find the derivative is not. So we just this method. Okay. So I'm sorry here.
Okay.
So, oh, I'm sorry here. The class is over. No. I have something to tell you. Okay. The last week I will not be in school. Okay. I will must go home. So the last week the class is stop. Okay. Stop. The last week do not have mathematics class.
Okay.
And so we have six class. This 6th class, I will make up it, okay? So this week actually is 15th week, yeah?
Yes.
This 15th week, this is end. And next week is 16th week. 16th week, I will not be in school. So here, and so from the 17th, the 18th, and the 19th week, this is 3 weeks, okay? This 3 weeks, we have 8. Each week we have 8 class. 8 class, okay? 8 class. So here 8 class, here 8 class, here 8 class. This we have 6, 2, 6, 2, and 6, 2. This 2, okay? This 2 actually the make up this one, okay?
Oh my god.
Okay, you understand?
This is gonna be crazy.
So actually, here we have 6 here, but this so this I should do make up this 6. So this 6 is in here. 17 we make up 2. So 18 we make up 2, and 19 we make up 2, and at the end of 19, of course the examination will be in the 20 week, okay, the 20th week. You need what?
1 week.
Review class. Yes.
Review class.
Review.
Class.
Yeah, review.
Let's have
Review class.
Let's have
So this means you. So I should give you a review class. Yeah.
Yes.
I hope I have time. Okay.
Okay.
The first-
18 and 19. That's it.
The first I must finish chapter 10.
Okay.
And actually, the next semester we do not have math class.
Yes.
So here this means what? This means when I finish chapter 10 and chapter 11, chapter 12, chapter 13, and you should read it yourself, study yourself.
Okay.
Okay. And I think that if you have any difficulty, so you can find me, or you can to see the video. Okay, see the video on the internet. On the internet. Okay, so you can see the video of chapter 11 or chapter 12, chapter 13 of other teachers. Okay, see the video. Okay, see the video and study it by yourself. Okay. And if I have time, of course, I will give you a review, and I will tell you which is important, which I will test it. Okay.
Yes.
So from now on, I hope you can study hard. Okay. So the class is over. Thank you. So L equal to 0 times L, so here L is 0. Yeah. L不拘是它，主要是 L 不拘是
What? Yeah.
That's the last week. I'm sorry for this.
I have to run. Right off. Good shoes. Give it a Yeah. Give it to this guy. What? Today.
You have to add mark of the second exam. Yeah, so this is you. Yeah.
Now, sir, I went 2:30 and just now.
So I think that you can find another time to take.
I went 2:30.
2:30.
Yes, they take a lot of time. And we don't write time. I find the Chinese man too much.
Yeah. Oh, actually.
So I just want to ask you. No. Really?
You paid what? I don't know. You just take your passport, student card, money. Do you have Bank of China account? Yes, I have. So you can go there.
Hey.
This receipt is for what?
No need to make mad.
The receipt is for what?
This is receipt in here.
You went to open an account?
So only this school needs student, the Chinese student, right?
No need Chinese.
This is the proof. Why is
Just you have to write by yourself or you need help.
Okay, give me the paper.
You fill in all the papers, right? There's zero.
I didn't fill this. I didn't fill this. I just filled this. I will send you photo.
No, I
Don't
want
have
it.
this paper. You need to go
Because
back.
we have to.
Then you will find this paper.
Bank of China is just from his gate. When I go, you never can go to China. Okay, what's the point? You know, from his gate, you just go here. Bank of China is somewhere here.
Hey, you can take photo. Because maybe we have to submit this paper, to this.
You just even forget that.
Yeah, you can.
I think if we have money to our bank card, you can give them
Can I-
bank
I
card
can-
and ask them to.
Yeah.
Can I transfer like from ABC Bank on?
Yeah, I know, but I don't need to pay cash.
I can transfer from ABC Bank, right?
You can give them cash. No problem.
I can't give them
You know what
my
that's, you know Ajebale, she will come tomorrow.
Yeah.
Bank of China card?
I have.
In at 10, right? Next week we only have mechanics. Oh my god. The other week
I have money in my bank card.
Not China bank card.
But for me, I beg of China, but I don't have that.
Where have you do it?
Put it on your card.
Tomorrow I will come.
Bro, he has money on China bank.
Here.
Can give the within dates.
Yeah, you just give them card. You
Bank
will
card,
do
right?
everything.
No cash.
I can transfer like giving them cash. You pay
In the
for it.
school, but they need Chinese students. Yeah, so that's the difference.
You need Chinese student how?
The bank inside this school.
Actually, you don't have ethical bank account, right? So
Yeah,
that's why you.
That's why, yeah. But if you have a Chinese bank of China, it's okay.
If I don't have
The reason why this is a ABC,
Agricultural
so
bank.
you don't have account there. But if you have this,
so I can deposit at ABC Bank.
yeah, inside the school. But you need a Chinese student.
You know, the communication bank and Bank of China.
If you need take cash.
No, I can just take cash with ABC is near me. How can I go put in here?
But you know, the ABC inside the school now, you need a Chinese student to help you.
So I can call the Chinese.
Yeah, so cash.
I'll call Boris. I'll call my friend.
No, you have to tell them because maybe for some,
I'll tell him.
you have to go and then
He said he has been recently busy.
yeah, so take things now if you are going to.
Bro, what's that? Solving riddles and making Chinese notes. And some root game with a lot of fun. That's this. Search Google. What's that?
My phone, I have to connect to VPN.
I think it's like again.
Oh, that's stuff. Yeah. Making Chinese notes. What's notes?